Hello everyone, welcome to the second part of the video for lab 6. In question number 2, we want to apply regression method for combining forecasts. So in this combining forecast process, as we're using regression method, number of accepted patients to act as a dependent series, and we have two independent time series which are forecast generated using Winters method and forecast generated using multiple causal regression method. Okay, so from here let's go to ForecastX. So I'm again using VLab for the ForecastX. So at this point I'm assuming that you have already created the forecast using Winters method and multiple causal regression, which was part of question number 1. Okay, so we will work with modified dataset Excel sheet. So we're going to do step 0. Why I call it step 0? Because we need to prepare sheet and how to apply regression. Okay, for step 0, I'm going to call column C Winters method and column D multiple causal regression. So we want to get the fitted values in column C for Winters method and column D for the multiple causal regression. From where you will get those values, you have already created forecasts using ForecastX, right, in question number 1. So simply going to use the data we have from ForecastX in order to fill the column C and D. So in case you're using VLab, you're on your main document in Excel. The only way to navigate back to the other documents which you have generated in the backend, such as any reports from ForecastX, go to the Restore Down button on the top right corner. So let's click on that. And once you move your main document around, you will have access to the other forecasts that you have generated. So at the moment I'm on audit of accepted patients. So let's scroll down. This is from Winters method. So here's the method selected. So make sure that you're selecting right fitted values. So these are my Winters method values. I'm going to select the fitted data. Let's copy this to the modified dataset Excel sheet. Okay, so we have the values for Winters method in column C. The same we're going to do for the multiple causal regression method. To go to the other one. So from this equation we can tell this is multiple causal model, right? So let's pick up fitted data starting from row number 143 to row number 214. So I'm going to minimize this. Have these values here. So now our step 0 is completed. We have all the required data in column C and column D, which is coming from the forecast we generated earlier using ForecastX. Okay, now let's move on to step 1. So in step 1, we're going to do a t-test for the intercept term in order to check if your intercept is statistically significant or not. So we're only going to move forward with combining forecasts if the intercept is not statistically significant. So in order to do this, we're going to go ahead with the multiple causal regression process. So I'm going to select A1. Let's go to add-ins, forecast method, multiple regression, and our dependent time series is going to be number of accepted patients. Go to advanced. Make sure everything is unchecked, right? Because this step 1, we still want to have real intercept values. So let's press OK. Press finish. So let's look into the results. So we are going to scroll down and locate the audit table. So here's the audit table for the coefficient table. So here's my intercept in row number 230. Intercept value is minus 137 and the t-test value is minus 1.15. Okay, so from here let's go to the Word document or the solution that was uploaded to the Blackboard. The very first thing, we establish the hypothesis. So you got your null hypothesis where intercept is equals to 0, alternative hypothesis or H1, intercept not equal to 0. Then step 2, we're going to get the T critical. So for that you will need degrees of freedom. There are 72 data points. Number of independent variables are 2, which is Winters model and multiple causal regression. That will give you 69 degrees of freedom. And if you use t-table from here, you're going to get the t critical value as 1.96, as is two-tailed test. So the value of alpha is 0.05, and we will use alpha over 2, which means 0.025, right? So that's why we have t critical at 0.025 comma 69, right? And we already know the t calculated from Ttest, which is minus 1.15. So it's a two-tailed test. Remember from chapter 2, one of the assumptions, distribution is symmetric around the center, right, or around 0. So which means if we only think about the positive value as 1.15 h naught, if t calculated is greater than t critical, which is not true. If you want to go by the negative value, your t calculated should be less than t critical, right? So in any case, we fail to reject null hypothesis. So by definition, when you fail to reject null hypothesis, this means the intercept is not statistically significant, or it is essentially equals to 0. The alternative way to prove this is look at p-values. In our case, the p-value is 0.25, which is greater than 0.05 or the significance level, and we can conclude that intercept value is equals to 0, which means the two forecasts are unbiased. And we can combine these. These are very good candidates for combining forecasts. So the next question is, how do we combine the forecasts? So we're going to go back for original data set, and we'll go through the process by applying the regression, right? So let's go to ForecastX, and under forecast method, multiple regression, number of accepted patients. Let's do the advanced settings. So I'm going to go to advanced, and we're going to make our intercept 0 or force it to 0. Then the next thing we're going to check the use existing values. So once you check this, ForecastX is going to use the values for the independent variables which are provided in this Excel document, instead of using some explanatory model to predict those values. So this advanced functionality is not available in Excel. So when you check this, your results will be different from what you're going to get from Excel. The next is remove empty values. So I always check it in case I have any empty cells, because you don't want to consider the empty cells when it comes to applying the regression method. So we have all these settings in place. Let's press OK. Important note here, because we're doing the auto. When you want to apply regression in some other questions, please make sure you uncheck these. Otherwise, ForecastX will save these settings and your results will not be accurate. Let's press finish. View output. Okay, so here are the results for combining forecasts. And if you notice here carefully that you have intercept 0. For interest method, we have weight of 0.184 and multiple causal regression 0.8247. And as I said earlier, if you go ahead and apply data analysis tool pack and use regression in Excel, your weights will be different. Okay, so you can give that a go and compare your results, what we got from here. Okay, so before we move any further, let's copy the fitted values, so which are here in column D. Let's copy to column E here in our original data set, and I'm going to call it combined forecast. So here we got the combined forecast. So let's look at the MAPE for the combined model. So this is my combined model, and the MAPE value for combined model is 8.83. So then we have multiple regression method, which we generated in question number 1. So for that, the MAPE is 10.63. And here's the interest method, where we have MAPE as 10.98. This concludes when you combine 2 or more forecasts, given that the intercept is equals to 0 or intercept is not statistically significant, then the combined model is always going to generate a better forecast than the individual models. So that concludes our lab 6. So I would like you guys to try the other combinations too and look at the MAPE value, root mean square error, and then you can decide which model is better. If you have any questions, please drop me an email. Thank you.